Hello and welcome. In this new tutorial, we're going to see how to recreate inside MotionBuilder the equivalent of Maya's set-driven keys, which allow you to remap the transform of a certain bone, here the arm rotation, and map it to control other bones, like here the shoulder pad, and how it starts reacting when my arm lifts far enough. This is meant for procedural little adjustments, so you don't have to hand animate certain parts of your character. So obviously we can see past a certain rotation, the shoulder pad clips because it's not solved, and that shoulder pad is skinned to another bone here, which I just made green, and that bone is parented to the clavicle, right? So if I rotate the clavicle, it rotates with it, but it needs to react to the arm as well. And actually, when I rotate the clavicle up, that bone could also potentially be pushed out automatically, so it doesn't clip into the head as much. And obviously, when it rotates like this, it should rotate like that. But we only want to rotate like that past a certain point, and we would also want to push it out. So there's some manipulations that we need to make. So in MotionBuilder, we're going to use a node in the relation constraint called FCurve. It's inside the other category. And we're going to use this FCurve to remap the rotation. So there's nothing directly called driven keys per se. And this node is not super intuitive to use at first. And why is it called a percentage? It's because it's going to handle our transformation between a value of 0 and 100. In fact, if you right-click on this node, and we've seen that node in a previous video, but you can see by default it has a curve that goes from 0 to 100 on both axes. So let's not focus on that node too much for now. Let's try to more understand the problem that we're going to try and solve here. What I'm going to do is start by working on an animation that goes from 0 to 100 to kind of follow what the node expects here. I'm just going to recreate a little override layer here. You could just go to another take, whatever. And I'm going to, define the range of motion. So here, I don't really need to worry about the arm lowering closer to the body here because that won't affect my shoulder pad. So I can just put a key here, and I'm gonna animate the arm to rotate as much as I want to cover, right? Technically, a creature wouldn't, or a human wouldn't really raise the arm like this without also rotating the clavicle like this. So, this is way more than the kind of natural limits of a body, so I think it's fine. It's just go beyond your limits a bit, just so you have enough coverage for the deformation. I'm gonna make those keys linear, so I'll just click on discontinued here, or select them, shift select them, and interpolation linear. Okay, that way it's just boop, interpolating like this without ease in, ease out. And we're going to look at the rotation of the bone, but I don't want to look at the FK controller. I just want to really just look at the bones. Why? It's because that way, when my character is in bind pose here, my local rotation are at 0 because of freeze transform. Whereas on the controller, there are some weird values here. It's not super intuitive to work with. So here, my rotation is at 0 because on my first key, the character is in bind pose. Technically I could have made, let's say I could have made the bind pose at 50, and here I could have gone a little lower like this, It's just to illustrate that you don't have to start necessarily from the bind pose if you need to have a range that goes, a little lower and a little higher at the same time. And here I will animate the shoulder pad accordingly. So that's where it gets nice and intuitive normally. It's because you can just, look at your animation and kind of animate where you like organically, I mean. So here, there starts to be some contact between the arm and the shoulder pad. So I will put one last key on this frame, and then after that, I will start moving the shoulder pad like this. And in fact, I will even, so always try to work with linear in this case. And then here, I would like start making the shoulder pad move. So let me see, I will go from here, raise it a bit more. And here you can see it moves too fast. So maybe bring that key back like this. Something like this, So now, just based on the rotation of the arm on one axis, you can see when I select the upper arm, it's just rotating on one axis. So that's why, again, you want to do all that stuff based on the local rotation of the bones, not the FK controls, because you can see here on my FK control, it's moving on all three axes, so not great. Just by driving with the upper arm's y-axis in this case, I will want to manipulate the shoulder pads. Let's see what axes are changing here. I obviously have a bit of rotation on y-axis, and x-axis moves a little bit. Y-axis moves quite significantly, and z-axis mostly. Okay, so I'm gonna want to work on those 4 dimensions. So, as always, there are senders and receivers. So the upper arm will be a sender, and the shoulder will be a receiver. Okay. Like I said, local space rotation, so right-click, local transform. All right. And we want to analyze the y-axis of the arm. So converter, vector to number. I will select the rotation. And now we can plug this in some math. We're not going to plug it directly in this node. We need to first understand how that node is going to behave. So, as I said, that node is going to remap things between a value of 0 and 100. So when I'm at 0, it's this pose here, okay? For this rotation, it's kind of like the value of 0 in the curve that we've seen on this node. And when I'm all the way at the end, this pose here has a coordinate of 100, okay? It's the end of our range. So intuitively, for this illustration, I've put 100 for when the arm is up and then 0 when the arm is down. If I look at the values, it also matches the value. You can see 50 I was in bind pose, so it's 0, 0, 0. And when I go towards 0, it's a negative value. And if I go towards the sky, it goes to a positive value. But that depends on your axis orientation, right? Depending on your orientation order, maybe the first pose you put here is actually, maybe it corresponds to the positive value, and then the value you have all the way there, maybe it corresponds to the negative value. So it's nice to have it in a increasing way. It's going to be easier to do the math. So maybe you can first, do what I did here, like select your bone, look at how the value behaves when you do your simple rotation like this, and if you realize, oh, when I go this way it's negative, then your first key in the time range in your timeline should probably be disposed and then go up. It's going to make things easier down the line, I promise. Okay, so we have a range of 0, 100, 50, and this is kind of like pose 1, pose 2, pose 3, right? So this, when we plug the y-axis here of our upper arm, we need to kind of convert that data, which goes from kind of random values, right? If I look at this here, for pose, let's say pose frame 50, it's 0, 0, 0. For pose frame 0, it's minus 24.12. And for this one, it's about almost 75. So, and that also would be a good idea to work with more like round values. So when I pose my character, it would have been a little smarter to use snap rotation, at least with a value of 5, just so the values we see here are easier to enter in the system. So in fact, let me go ahead and do that. I'll be smarter. Maybe I can round it there as well. Minus 45 here. No, not a good idea. So I'll just do this. Boop, boop. Let's go like do. Okay, I have snapping, so I know I'm gonna have like exact values. Okay. So see, this is a little better because now when I'm at frame 0, my upper arm is at exactly 25, and when I'm up there, it's exactly at 75. So nicer. So to rearrange the input y, we need to do some math where the value of you know, when this is at, let's say 75 degrees, it corresponds to 100. And when it's at 25, minus 25, it needs to be at 0. And this is our range. To remap like that, we just needed to do a little bit of math. We need to do we need to get the value of y and subtract the lowest value. So subtract the lowest value, divide it by the maximum value minus the lowest value or minimum value. Let me call that min. Okay, min. So that's why you're probably starting to understand why we put the minimum value here and the maximum value there. So in our case, it's y minus 25 plus, divided by 75 minus 25, which will be plus 25 in the end. Okay, so that gives us y plus 25, and then our range here. Oh, it's funny, it's 100. I didn't do that on purpose, but that range could be, that's a happy accident. Don't get distracted by that. That range could be, I don't know, 148 minus 10, okay? It could be something like this. It could be a totally different number than 100. This is really not super relevant, okay? And then, yeah, then we're going to multiply the result by 100. We're going to divide the result by 100. So we can do it with nodes, okay? We can do, so y You can do subtract. So subtract the lowest value. So it's to know how far is my current arm rotation from the lowest value of our range. So how far are we from that first frame? Not in terms of time, mind you, but just in terms of like rotation like this, okay? At this point, I'm at, here, for example, I'm at 40 degrees, plus 40 degrees, so, but my lowest value is like below 0, so it's, 40 minus 25, so it's 65. Okay, so around here, I'm in that pose, I'm 65 units away from 0, and we remultiply that 65 degrees by the total amount of degrees that our range covers. So, okay, we start with minus the lowest value. So here I just have to type in minus 25. Then we divide by the total range. Okay, so how far are we our current pose from the lowest value, and let's divide that by the total range. So divide, and here I'm going to do another subtraction, but this time I'm going to enter here in A the maximum value, 75. Honestly, guys, I don't like that I chose something that ends up being 75 minus 25. So I really hope you don't get confused by that range. Let me make it I don't know, something random like this. Just gonna change my values a bit, like 50. Let me do that, 50. So my character reaches 0 around here. So I'm just gonna change a bit my keys again to be like that. Boom. Okay, so I just changed things a bit. So here we have minus 50 and here minus 50. It's also to show you that, hey, if you change your mind, you readjust your range, it's not that hard to do until you start making the poses of your child bone, right? So we subtract our current value from the lowest value. We subtract the maximum value from the lowest value. We divide one by the other. Can I just print that? Let me see. What I'm going to do is on the shoulder, I'm going to add a little properties. You don't have to do this. This is just for the purpose of the tutorial, so we can, I mean, maybe it will help you debug, but this is so we see the number that we get. So I'm going to give you a number here. I'm going to call it like a print. I don't know if there's a print node. I don't think so. Print that number, minimum value, whatever, minus 360, just big range, so we see what's going on. And this is going to be animatable. Okay, so we can print it here. That way, by looking at the number here, we will kind of know how much is. Oh no, I mean I just need to plug it and do right-click, show all values. The thing is, if this is plugged into nothing, even if you do like show all values, it won't show anything because this is not being calculated because it's not plugged anywhere. So you just want to plug it somewhere. I'm just gonna reselect my upper arm. Okay, so I still see the upper arm value, but here I can do this so I know how much is the range. So now you'll notice that if I go all the way down at my first frame, so the minimum of my range, and again, keep in mind, time doesn't matter here. It's not about 100 frames at 30 FPS. It's about the 0% range or the 100% range, like minimum and max, okay? This is a percentage timeline from now on, not time. So when I'm all the way down, you see this returns 0, and when I'm all the way up, it returns 1, because we are dividing our maximum range, because right now my upper arm y-axis is as far from the minimum value as the range allows it to be. So it's all the way at 1. And obviously this node expects a percentage, not a normalized alpha value between 0 and 1. So we're going to simply multiply that by 100. Poof, poof. I'm going to plug it here so we see the result. Show all values, and now you can see, oh, it's a percentage. That's great. That means this node here is going to be able to understand this. Okay. So this is how you would set it up. So this would never change. What would change is those 3 values here, right? In fact, when I do this, I take a little bit of shortcut. So I'm just going to show you the nodes I use when I do this multiple times. I want to, take in some shortcuts. I do this minus that divided by the range. So this first part doesn't change, the subtract minus the lowest value. But here I kind of combine those 3 nodes by putting a certain value here, where I do this minus that, and I divide it by 100. So in this case, I do, and I literally use this calculator thingy all the time. I do 75 minus 50. Well, I have to type in plus 50 here. So 75 plus 50. 75 plus 50. 125, that's the absolute total range that I have. Divided by 100, so I just have to move the dot twice to the left, right? So it's 1.25. And you will see, if I plug that here, show all values. Did I do something wrong? Oh, I'm just not giving it the input. There we go. Gives me the same thing as before. I just don't know why. Oh, this is not plugged anymore either, so this one is not refreshing. Let me just do like a sorry, just don't worry about that subtract. It's just for the sake of being able to see those 2 values at the same time. I just plug them in something so I can do show all values and see those. I just want to show you guys that it's the same result doing this with like all the scattered node versus the condensed version. You can see I'm at 0%, ramps up. At frame 50, I'm around 62. I'm not sure why. And around here, I'm at 100%. Okay. So this is how you can rearrange things to get a percentage. Now, what do we do with this number thingy? Well, we're going to need several of them. So I'm just going to delete that. Because we have several dimensions to manage, right? So converter number to vector. We're going to need 2 of those because we are working both on translation and rotation. So the node here is going to be to convert the percentage we created into the transforms of the shoulder pad that we've hand keyed over there. And the cool thing is, because we keyed here on a time range that goes from 0 to 100 in the correct order, because we went increasing, right? We put our lowest value on the far left and our highest value on the far right. So it's the numbers are in increasing order. We're simply going to be able to take this, copy the keys, and paste them in those nodes. In fact, let's just do that. Edit. Just make sure when you do that, you are on the base layer, because it's a little weird, but if you edit those curves while being on a layer, it's kind of, it's losing it. It's quite strange, I reckon. So in fact, it would be smarter of me to just bake my control rig, and I'm not going to bake that, but I'm going to copy those curves back to the base layer. It was, yeah, a little silly to just to work on that override layer in the first place. So yeah, if you work with additive layers and stuff, just be very careful. Go from one to the other. Boom, boom, boom. Does that work? Yes. Okay. So we can get rid of that useless little override layer. So okay, so I'm on a flat layer, and that's way better. I can just go in here and edit with my FCurves available also somewhere. It's just hard on one screen. Okay, so let's go. We said we wanted to work on X, Y, Z, and Y rotation. So I'm going to need X, Y, Z, and Y rotation. The others two here will stay at 0. We're not doing anything on them at the moment. Boom, 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 boom. All right. Okay. So for now, it's still what I've animated. Okay, it's not solved automatically just yet, but I can go in here. Okay, so be careful. You often want to click close that. Just right-click on the certain node. So now you know you're on. Actually, I'm gonna put that here because it's like rotation first and translation after, because it's alphabetical order here. It's not the conventional TRS order, so I'm just putting translation here. So starting with translation X, let's go here, translation X, copy all these, and right click, edit, and then while being at 0 here, you want to paste. Does that not work? Edit, paste. Okay, what's going on? Maybe it didn't copy the keys properly, because sometimes this is a little buggy. Okay, so you want to make sure that when you select and you copy, if it worked properly, it should deselect your keys afterward. You see they go from this dark red to this lighter red. And now I can paste. So on the vertical axis, you have actual values. Okay, they're not going to be from 0 to 100 necessarily. It's whatever value that transform your bone. Okay, but on the horizontal axis should still be between 0 and 100 because we've remapped here. Because technically you could also say that you could remap things horizontally to say, if you weren't doing those math here, you could say, okay, from minus 50 over there to like 75. You could remap it like this also. So here I have the values of the bone child, and on the x-axis I have kind of the values of the upper arm range. But honestly, that's way harder because every time you're going to want to tune the range, like you're not iterating on the range that much, but I find it way less intuitive because that means you have to kind of manipulate your curves on two axes. Whereas with the solution I propose, the fact that you remap, you just remap here, and that's going to apply to all your dimensions. You just have to literally just copy paste the keys and you're done. You don't have to hand adjust those curves here. Maybe you can just set them to literally just linear. That key is useless there. Or if you think it gives you better results to automate to make it smooth, but I wouldn't recommend it. Well, maybe like on the keys here if you want to smooth it out, but not this. I wouldn't do that. For this kind of more like mapped stuff, it's not always the best. And I'm just going to repeat that for each axis. Just be careful if you right-click edit on another box, you have a second window popping up, and you can easily get lost. So I recommend closing every time. Just going down to like whatever, blah blah blah. What does it say? It doesn't let me change while the pop-up is on. So just go to your new dimension, copy the keys, right-click edit, go to frame 0 to paste your keys. Boom. Close this. You can verify if you want. Up the interpolation. Close this. Go to your new dimension. Right-click. Wait. First, copy. Right-click edit. Boom. And then finally the rotation on Y. So go here. Copy. Right-click edit. Boom. Okay. Okay. If you've done things correctly, once you plug that here, you shouldn't see your bone doing some weird thing, especially if you're like in bind pose, which for me is like somewhere here. Boom. You will know you've done something wrong is if when you plug your bone end up like some weird spot like that or whatever. Okay, and now it might look like nothing happened, but the thing is that now, up until now, the shoulder looked correct because we were just scrubbing through the animation where we manually posed it on each kind of on each frame pretty much. But now it's actually driven automatically by the system. I know because if I stay on one frame and I now control it manually, it adapts automatically like this. Okay, so obviously with big ranges, if you start like making that arm go beyond and like rotate, this starts breaking because in local space that rotation starts going the other way around. I mean, there's no secret, that's just Euler interpolation, there's no big way around it. So here I get a little bit of weird result because it's a little strong. Maybe there's something wrong with my range. It shouldn't reach this pose this fast, right? Show all values, range, multiply by 100. It's weird because when I'm in this pose, it's already at 1. So there might be something wrong with my range. 75. There's something wrong. So I entered the coordinates a little bit bad, and that's because my range is a little too big. So you see here, for this whole part, just my y-axis is changing, and the two other axes are at 0 because I didn't do any forward or twist motion. But around here, if you notice, up I go past 75, even though I'm not all the way like on the last pose. But here I pass beyond 75 and I keep getting towards 90 degrees. Oh, and I'm past 90 degrees. So here you see 88, and the next frame, in fact I can go like play on frames if I want to go inside the frame. You can see up 89.80, and then once I go past 90 degrees, the values on the two other axes added 180 degrees. So technically, if I keep rotating this way, it's as if, so our limit was here. So imagine there's like this kind of like hemisphere here. So I started, this was 0 degrees. and here I went like plus 90 degrees. Okay, and I went beyond that range. Tuk tuk tuk. And so if I keep going down till the last frame, I reach 75. But this is not just 75. It's 90 degrees plus that extra delta, so plus 90 degrees minus 75, right? I think you get that. So it's 90. Well, so distance between 90 and 75 is just 15, so it's 90 degrees plus 15, so it's 105. So actually my maximum range here is not 75, it's 105. And I think here you see the advantage of handling the mapping there rather than inside the curve's horizontal axis. Because if I didn't use that kind of normalized range between 0 and 100, if I try to like move the curves here to represent my min and max value, I would have to update 4 curves now. Well, that's not ideal. So now I think I fixed the problem. I hope. Yeah, that's the behavior we were after. So this concludes the first part of our tutorial, understanding the basic setup. But there are a couple more tricks I would like to show you. So remember, here we're handling just the upper arm rotation, but there could be also some clavicle rotation that we want to manage. So I highly suggest working on different takes like that for setting this this up. So this would be my clavicle take, So same thing. So we'll redo what we did a little faster. So time range of 0 to 100. I'm gonna just go towards the highest pose here. Okay, I don't care about going lower. That was just for the demo. In this case, I just care about this going higher like that. Okay, let's go a little crazy on the range. A bit more than what you would animate. Let's make those keys linear. And let's animate this. Obviously, my shoulder is currently solved by our first relation here, so I would just deactivate it for the time being. Okay, so let's key first frame here, and I will secure a key before it starts clipping, and then I will move after that. Because if you just do like maximum here and you push this out somehow like this, and you just leave the first and last key, it's missing the purpose of the driven keys, which is to remap progressively. Like I don't want the shoulder pad to start moving like this before there is clipping. I want to kind of fake that collision. So that's why I'm like kind of protecting it with this key here, the first key. Here I'm gonna copy the first 0 key, and here I'm gonna start interpolating to the offset. So as always, linear key. What I can do is maybe copy the last key and like kind of dial it back like this. Okay. I can. The idea is to the idea of the FCurves is to make that map non-linear thanks to the curve. Okay, so this is interesting. So I'm going to grab the clavicle, send it as sender. Local space. I'm going to put it here in the properties. Oh, I made the same mistake as before. I didn't use the snapping. So if I select the clavicle here and lock the properties, see on the last frame I'm at 60.01. I'll just round it to 60, that's fine. And it's the y-axis once again. Okay. I guess I'll copy that. I'll copy the stuff here. I'm not copying the FCurves because they're going to have completely different values, so it's just easier for me to start fresh. So rotation of clavicle right is going to drive this little thing, and it's going to drive that after a few FCurves, and then it's going to plug into here. And we'll see how to combine this and that. You'll see it'll be pretty easy. Spoiler alert, it's just an addition. Okay, so we need to remap, like change the mapping values. So here, because we're just moving in one direction away from the bind pose, okay, we're just doing a rotation like that. So I know I start at 0 and I go towards something, so I don't worry about going down there. So I'm just going to make sure here clavicle goes to... Huh, that's interesting. Why is it? Do you see that? I go towards the negative here. So you remember before our upper arm was like in our timeline, as our timeline increased, it was going from a negative value to a positive value, so it was increasing. But here it goes from 0 to minus 16. That's what I explained before. It's like, it's just kind of the rotation order. It's a little random. I mean, it's not random, but it's like however you pose and oriented your bones. So if we leave it like that, and if we do the mapping exactly the same way, so you know, if we do minimum value, if we do minus 60 here, because it is our minimum value, and we do maximum value 0, the problem is that doing that is gonna map our percentage from 0 to 100%, but expecting that 0 corresponds to minus 60 degrees and 100 corresponds to 0 degrees. But here it's the opposite, because the pose that corresponds to 0 degrees is all the way there, and the pose that corresponds to minus 66 degrees is all the way there. So our range is flipped. Okay, so if you if you keyed and you realize after the fact that your timeline is going decreasingly instead of increasingly, you can flip your mapping by adding this multiply by -1 and add 100. Or, and I think that's better, in the end it's cleaner, kind of swap your curves. So I would switch the clavicle keys around, but I also need to switch the poses of the keys of my shoulder pad, which is a little more cumbersome because there are more of them. So I mean, it's not that hard in the FCurve editor to, well, you know, you can do it like this and then exactly 200 and move it back, probably before copy pasting them. And then FCurve nodes, the other category, FCurve's percentage. Okay, don't use time. We need one here and 3 over there. Boop, boop. Okay, and I'll just go ahead and copy the curves I have here. Alright, so I copy paste it a little faster. And so I'm going to unplug the ones we had before and plug these just to verify that that new clavicle setup works. I'm going to reactivate the relation. Yeah, so if we See here, it's mapped like this. It's a little strong. You know, you could add some damping if you want, as always. You could add some damping, like either a vector damping, like a 3D damping after the vector, or a number damping for each individual axis. Up to you if you feel like this is a little strong here. I mean, you can also decide, hey, I just want less of it, so you could add a multiplier just there after a percentage. Yeah. So between the percentage and the FCurves. So now you see it's 0. It's not solving at all. And I can add 1. It's solving completely, but my pose are a little extreme, so you know, trade-off. Do I want a bit of clipping? Do I want some awkward kind of offset? So I could put 0.5. That's just a little softer, a little more subtle. Okay, but to achieve this clavicle solve, remember we've unplugged our upper arm solve we did before. So now when I raise my arm, nothing happens anymore. I told you it's just a simple addition. So at vector level, I can take those outputs and do addition there, add. So if you just solve for 2 parts here, I just have 2 drivers, clavicle and upper arm, 1 dimension each. I can do just an add v1 plus v2. If you have more than that, you could use the sum temp vectors. So you can add a bunch of vectors all at once. So I'm gonna add the translation together, plug it into translation. And is there a separate node for rotation? Yes. For rotation, you want to use this one. It's gonna handle the 180 degrees kind of limits. So rotation, A, B, boom. Is there something wrong here? Oh wait, I'm doubling up on everything. That's not a... There's more to it. Because I did local translation plus local translation. Yeah, that's just adding the offset from the clavicle like twice, even when I'm here in bind pose. It's because the offsets I've worked with in the FCurve nodes, they don't represent a delta from my bind pose. They represent a delta from the parent bone, because there's a difference between what we call a local space transform, which is if I unplug these, the local space transform of a bone here, it's how far it is from its parent. So in this case, it has a few, a little translation offset from the parent here, the clavicle that's there, and potentially it has some rotation offsets. Usually we freeze the rotation of the offset, so it looks like it's 0, even though technically it might have a little offset from the parent. So you can see that in degrees of freedom pre-rotation. So in reality it has this rotation delta from its parent, but we don't have that frozen transformation on the translation. So the translation really displays the offset from the parent, and so that's local space. But there's also what you would call kind of bone space. Sometimes it's called in Unreal, or just offset from bind pose, which is knowing that this is my bind pose here, this point there. It's like, how far do I move away from that pose? So it's not how far I am from my parent, it's how far I am from where I was skinned, if you will. So in this case, we're working with local transform, not offset from transform. So to fix that, one thing you could have done is like kind of adding a null, okay, positioning that null on the bone, and then potentially parenting that null to the same bone as the joint itself. So I have this one, and then making a second one. So copy paste, Control C, Control V, and have that one. So that one is kind of like group shoulder rig, and that one would be like offset shoulder rig, for example. And that way, that guy here is at 0, 0, 0 by default, and you would have animated your poses from there and constrain the shoulder bone to this thing. If I do it now, it means I have to kind of readjust all the curves data I have here. Okay, so I'll just be lazy, and I think I just have to fix the translation anyway, because the rotation is frozen transform. So I'm just going to subtract the bind pose value. I'm kind of going to do a frozen transform, if you will, by just doing vector subtract, and I'm manually going to enter the default the default offset. So in fact I have the values here. See, this thing here and this thing there, those are the values while I'm in bind pose. So I can actually copy this. So I'm able to do this minus 7.61, 0.25, and minus 6.16. So given that I'm inputting these values twice, because I have those two kind of sets of driven keys, one from the upper arm, one from the clavicle. They add up to each other, and that pushes my shoulder twice as far as it should. So I'm just subtracting it once to kind of reset the transform. And now I think it should look better. If I rotate the clavicle manually, I see the solve happening here. And while the clavicle is solved, it's also going to add up the transform of the arm if I do it like this. So we have both at the same time adding onto each other. Okay. So what we've accomplished here is nice. If I select the upper arm, control, and I move, everything reacts. And you can see when I print on the upper arm, things move just on one axis here. But if I go forward, of course the other z-axis reacts. And here I have no shoulder pad rotation reaction, so I would have to add another set of poses here plugged on the upper arm z-axis, just like we added the clavicle y-axis. So for the same input object here, upper arm, if I want to solve for another axis, it's like another input entirely. So the setup can be a little cumbersome with more complex situations, because we're kind of mapping each axis of our driver to the shoulder pad every time. So it's very kind of manual. You could think of a different approach by using an IK solve and using the FCurve to turn on and off that solve at the right moment. So here, when the arm starts colliding with the shoulder pad, I could set up an IK constraint. For this, I'm going to need to create a child of the shoulder. So I'm just going to duplicate that bone and parent it here. Remove all the keys on it. Align it. Call it shoulder right child, for example. Offset it like this. Okay. So that will be the child for the IK solve, and I'm gonna create the same thing, and I'm gonna create another bone. So let me Control C, Control V the child again and parent it to the upper arm this time. I'm gonna call it shoulder right IK target. Okay. Let me put that one in blue. So that one is in the same spot. Maybe I can change the look so it's clearer. Okay. It's parented to the upper arm. So when I rotate the upper arm, that blue bone is going to follow. So this will be the effector. The shoulder pad will be the first joint, and again here I'm working directly on the bones. Probably a better habit to work on a set of locators, and constrain the bone to these locators or markers at the end of the day. So just work on the bones directly for the purpose of the demo. So the shoulder pad child will be the end joint. And now I can snap my constraint. Looks like nothing happened. But obviously if I move the arm around, shoulder pad always follows now. And that's too much because when we go back down, it clips through the other part of the geo. So we can use our relation constraint now to deactivate the chain IK. So I'm going to make the weight of the chain IK constraint animatable. So I can drag and drop it in the relation constraint as a receiver. Okay. And now I'll create a new FCurve. I will in fact deactivate our old solve. So this IK setup would be in replacement of the entire like axis per axis hand keyed solve. Okay. But you can still do like two solves, one for the clavicle, one for the upper arm, and activate that accordingly. So anyway, I grab the same ranging I had before, plug it in the FCurve that I just created, and I'm gonna edit that. In fact, I'm gonna plug that here so I can see the value, show all value. So currently we're around 45%. So I can add a key directly here using the button M. So I hold M and I mouse click button, middle mouse click button, like this. Or you can probably use the button key over there. And I know at 45% or 46%, I want the constraint to be on, so I'll set it to 100%. And just before that, as my arm is slightly lower than that, so just before kind of the fake collision, I'm gonna add another key and set it to 0. I can leave this to automatic or linear, whatever I prefer. So now when the arm is lower than this, there's no contact, and when it enters this, the IK kicks in. So I have a little area in between where the IK is not fully working, and beyond that the IK is fully working. So that's a base. I mean, you can see there are limitations, but that's just because of my IK solve. It's a little clunky in some places. And also here it turns off because I think my upper arm y-axis, what is it doing? The upper arm y-axis, when I go forward like that, it ramps down. So I would probably want to combine the z-axis and add the z-axis into the mix to say that the IK is on if y-axis is more than a certain value, or if z-axis is above a certain value or below. So I would want to use both axes. And of course, when I go too far up, like the pivot point of my shoulder pad here being quite low, it creates clipping here as well. So I can also use the original setup and control the translation of my shoulder pad in combination with the IK to make it move like this. I mean, it's a little broken here. I would again want to work on null parents to move the entire block. Okay, so could move this whole thing here as the IK is working. So just to say that you can use this whole FCurve setup in combination with other type of constraints. Okay, that's just a little preview of what can be done. Finally, another use case of the FCurve would be to remap an animation into a slider. So you can see here I have some kind of little prop that has this pretty complex deployment animation. And let's say I want to reuse that animation in a bigger scene, and I want to be able to quickly like deploy and fold like this. So I could create a relation constraint and use some kind of attribute to control the deployment. So on a random bone or controller, I would add a number and call it deployment. So I would make it go from 0 to 100. Make it animatable. Use that as a sender. Obviously I have a large number of little bones here to manage. So just for the purpose of the demo, I will just worry about this main one that folds in, if you guys don't mind. Use that as a receiver. Okay. And using the other type, FCurve, so I can plug directly the deployment here into the FCurve. Hide unconnected. And I would grab the FCurves of this bone. So I have a bit of transformation on translation and on rotation, translation X and rotation X. So I'll just worry about those two dimensions. So if I plug the FCurve number into rotation, I'll get this node. So I need the same node for translation X. I want to work on the local transform. And actually I need two different FCurve nodes because the curves are different per axis. So every time you need a different FCurve for each axis of each bone. So here I would probably have a bunch of bones listed over there. Remember to just go in here, rotation X, copy this, and edit, copy it there. Translation X, edit, paste. So notice that my animation here is over 30 frames. So I need to remap, I think. Oh no, it works out of the box because my attribute here, deployment, goes between 0 and 100, so we're good. You can see now it's doing this. So now I just rinse and repeat for the other bones, the other dimensions, but you see the interest is to nest a complex animation under a slider. Of course, if certain bones have the same motion, like those two little joints here, you can see their x-axis movement is the same across the animation. I have the exact same curve for both. I can just copy this curve in one node and use it in two nodes. I just made sure to also bake in the translation on Y that those bones have by default, even though it's not animated, since I'm plugging this number to vector node in the entire translation. I want to make sure I don't break the value on the other axis. So translation, and you can see I'm also handling the sliding back of those two bones. In the original animation, I also have some scaling, some non-uniform scaling on Y and Z, so I can also do that. Okay, here on another FCurve, edit, pasting that, and this one can control the scaling of the Y and Z axis at the same time. Okay, I'm doing a non-uniform scaling on two axes. So, you know, depending on what you're working, some machinery, some axes are kind of shared. So now I can plug that in the scaling of those two bones. You can see it does the same effect as the original animation. Okay. And for the all those joints here, you see, I do these things. I could also share some values. You know, if it's a radial value, maybe the z-axis of this guy equal the minus z-axis of the other guy. So I could use some multiplier doing -1, and then I could plug the z of this guy into the y of that guy, and vice versa. So on mechanical and symmetrical pieces like this, you can simplify. But yeah, I hope that gives you some ideas for your own projects. Thank you very much for watching, and have fun with your relation constraints. Cheers!